Jocelyn, help us find letters. What am I going to write above or below this? How about a D? And you factored out a 3?
Yeah.
Go ahead and read it to me.
What?
2. Yep, 2.
Oh. 2 divided 3 parentheses x minus 5 6 parentheses.
So 3 times x is 3x. 3 over 1. 3 times pi is 3 pi. 1 times 6 is 6. 3 pi over 6 reduces to pi over 2. Raise your hand if you got that. Remember, if you're stuck, this is my box method. 3 times the box will give you pi over 2. 3 times the box will give you pi over 2. Class, how do you get rid of that 3? So the box is equal to, multiply across, you get pi over 6. Okay? Thank you, Jocelyn. How about Brianna? What is your A value? B value? B. C? And D value. So no vertical shift, none. Brianna, what does pi over 6 mean? She says right. Thumbs up, thumbs down? Going to the right is correct. Partner A, tell partner B the formula for cotangent for the period. Vita? Echo? Yeah. Substitute in your B value, what do you get? Raise your hand if you got pi over 3. And Vita, what do we know about our A value? Is the amplitude 2? Yeah, it's fake. Don't be a teenager. Don't be fake. Don't try to impress others. Just be yourself. Alright, let's go ahead and draw our values. Count with me. Ready, set, go.
1, 2, 3,
Too fast, too fast.
5.
Yen, what am I going to put here? Correct. Yen, what are you going to put at the origin? Yeah. So, this is how I describe my equivalent fractions. In this pen length, they're all going to be denominators of what? 3. Now, as I double them to go on to more equivalent fractions, class, go ahead and double this. What do you get? 0 pi over 6. Double this one, you get what? 2 pi over 6. This is the one I can now take the midpoint of. Frida, what is the midpoint of 0 pi over 6 and 2 pi over 6? Pi over 6 is correct. Right? 0 plus 2 divided by 2 is 1 pi over 6. So everything in blue here has denominators of 6's. Remember, I do not want 1.5 pi over 6, so that's why we're going to double them again. Frida, go ahead and double all of these values. Good. Two pi over, we're multiplying by 2 over 2. 6 times 2. 12, and go ahead and double this one. Four pi over 12. Kevin, 0 plus 2 divided by 2.
Oh, you know, 1.
So this becomes 1 pi over 12. Now we're just counting by ones, right? 0, 1, 2. Kevin, this one will turn into 3 pi over 12. In pink, let's write the most reduced one. Kevin, or not Kevin, Henry, what is the most reduced one I'm going to use here?
0 pi over 2.
Yep, here?
Pi over 12.
Yes.
Pi over 6. 3 pi over 12.
And if you reduce that, what do you get?
Pi over 4.
And here.
Pi over 3.
Pi over 3. Uh-oh. We forgot something. Talk to your partner. 20 seconds. Ready, set, go. Erica, tell us what I messed up on. The values aren't the same. What values? No. Charlotte? Where's Charlotte? Hi, Charlotte. Where are you? There you are. Corner office. Nice window. You could be supervisor. Yell at all your workers. What's the mistake? Raise your hand if you see it. You're going to say a letter on the count of 3. 1, 2, 3. Yeah. You see, the C value tells you that you're being shifted what? To the right. So the graph doesn't start at 0, it starts where? That first point at pi over 12. So that means my graph's actually going to finish at this point. For cotangent, your period is how long? Pi over b. So everyone say it doesn't matter. You can actually put the purple or anything to the right of the trig function, whether it has a c value or it doesn't. Okay. If I put this in here, this inequality is going to tell us. Here's a classic mistake. Class, should I divide by 3 or add pi over 2?
Add pi.
You're doing PEMDAS backwards when you're solving, right? So I'm going to add pi over 2. Class, this one will become pi over 2. What's left? 3x. How do you make pi a fraction? To get a common denominator, I'm going to have to multiply by. So 1 plus 2 gives us what? 3 pi over 2. And then how do I solve for x? Okay, remember, dividing by 3 is the same thing as multiplying by 1/3. Does that make sense? So I'm going to multiply by 1/3. Then we get, multiply across, you get what?
Pi over 6 is equal or greater to s is equal to greater to pi over 2.
So we're going to start at pi over 6, and we're going to end at pi over 2. Raise your hand if you got that. Okay, let's double check. Let's go down here. This is my starting point. If it's shifted off from the origin at pi over 6, there's my starting point. We did a bunch of work with equivalent fractions, and I made a mistake, so let's correct it. 1, 2, 3, 4, 5. Class, this one's going to end at what?
Pi over 2.
Pi over 2. Because you have a, well, it's probably only skipping 1. I made a mistake yesterday in our equivalent fractions, so I just know it's being shifted off. So I was just making equivalent fractions, and then I realized I made a mistake. So I'm going to double check all these points right now. Let's check that we're right. 1 pi over 6. And to get a denominator of 6, I'm going to multiply this one by what? 3. So this is equivalent to what? 3 pi over 6. So 1 plus 3 is 4. And 4 divided by 2 is 2. Remember, I'm not going to write 2.5 pi over 6. So I'm going to double these. So 2 pi over 12, 4 pi over 12, and this will be 6 pi over 12.
I love math. You don't love math?
And
What's
then the
wrong
ones
with
that I'm
you?
really looking at are 2,
I love
3,
math.
4. This one will become what? 5 pi over 6. So let's circle the ones that are reduced. Over 12. And let's go ahead and circle the reduced ones. So pi over 6, pi over 4, pi over 3,
Pi over 12.
uh-huh,
And pi over 2.
pi over 2. Raise your hand if you got those. Let's go ahead and put that in our table now. Do they still have these books called Choose Your Own Adventures?
Yeah.
Have you guys read those books? You read a paragraph and it says you go to the woods and you read the woods. You're gonna go. You can choose go to the left or to the right. If you want to go to the left, turn to page 16. If you want to go to the right, turn to page 25. Does that make sense? So, in math, we're kind of at that same point. You can kind of choose your own adventure. What does that mean? You can choose to evaluate your equation either using the first one or the second one. Class, does it matter? It does not matter. Your table might look a little bit different, but your end points after you evaluate will be the same. Anybody got a birthday this month?
Huh?
Anybody got a birthday? Yes, Eduardo. Which one do you want to pick? Top one or the third one? Third one? All right, let's make this very clear. This is the one we're going to... Oh, I should use it. What color have I not used yet? Super dark color. We're going to use this one to evaluate. Okay? So class, what do I do with my x values? Partner A, tell partner B, what do you do with your x values? Here's your x value. Class, what do you do?
Move to the right.
Okay, so as you're working from right to left, you're essentially doing PEMDAS. So we're working within the parentheses, and in the parentheses you still do PEMDAS. There are no exponents in here. Inside the parentheses, there's no multiplication, division, there's addition and subtraction. So we're going to subtract pi over 6. Take my x values and subtract it by pi over 6. So x minus pi over 6. So class, 1 pi over 6 minus 1 pi over 6 is 0. You can use what's below. This is going to be 3 pi over 12 minus 2 pi over 12 gives us what? Pi over 12. 2 pi over 6 minus 1 pi over 6 gives us what? Pi over 6. 5 pi over 12 minus 2 pi over 12 gives us 3 pi over 12 reduces to what? Pi over 4. And 3 pi over 6 minus 1 pi over 6 gives us what? And 2 pi over 6 reduces to pi over 3. Partner B, tell partner A, what do we do after subtracting pi over 6? Class, should we evaluate cotangent or multiply by 3? We're going to multiply by 3. Do you see this? You're trying to find that golden row for tangent, cotangent. Class, 3 times 0. 3 times pi. 1 times 12. 3 pi over 12 reduces to pi over 4. 3 times pi. 1 times 6. 3 pi over 6 is pi over 2. 3 times pi over 4. And 3 times pi over 3. You get pi. Class, what do we do after multiplying by 3? Now we're going to evaluate at cotangent. partner A, tell partner B what are the letters for cotangent. Rochelle, what is the letters of cotangent? X over y. Remember, if you forget, you can always just use the reciprocal of tangent, right? Tangent is y over x, you just flip it over. So, we're going to go to 0. Class, what's the order pair? Class 1 divided by 0 is? Huh? Yes. Pi over 4. 1, 2, 3. Radical 2 over radical 2. X divided by y. Radical 2 over radical 2 is? 1. Pi over 2. Order pair? X over y? 0. 3 pi over 4. Order pair? So negative radical 2 over radical 2. And pi, what's the order pair? Negative 1 comma 0. Negative 1 divided by 0. Undefined. How does this relate to yesterday's lesson or the day before for tangent? If you evaluated these at tangent, you could just take your answers and take the reciprocal. Does that make sense? For example, tangent at 0 is 0 over 1, which would be 0. Or you could just flip that and get 1 divided by 0, which is undefined. And the last thing we need to do is add or multiply? Multiply by 2. Let's multiply by 2. 2 times undefined. 2 times 1. Here. 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 Oh, I did my table too close to the graph. It's okay. Okay, at pi over 6, I'm going to draw undefined or vertical asymptote. Here is pi over 6. Here is my vertical asymptote. And at pi over 2 is also undefined. Now I need to write something on my y-axis. I notice that my values are max at 2. I'll just call this one 2. I should have made my table like way higher than the graph. 4 boxes, 4 boxes. Pi over 4 and 2. Pi over 3 and 0. 5 pi over 12 and negative 2. And then pi over 2 undefined. And what's nice is we have one graph. I don't have to graph more because I can clearly see the snake or the river. My 3 dotted lines should be linear. 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. Yeah. I just want to show you guys one more time something. If you choose not to use my method of using the table of values, this is what it would look like. And you would essentially just do what you're doing right here. Let's just say I pick pi over 2. And let me prove a point by just using the one above. If I put pi over 2 here, pi over 2 times 3 is 3 pi over 2. 3 pi over 2 minus 1 pi over 2 is 2 pi over 2, which is just pi. Cotangent at pi is undefined, and 2 times undefined is just undefined. So essentially what it is you're doing the same thing, we're just doing the mass production of those values.